You ever stop and wonder how our digital world actually, well, works? How it all stays organized? Today, we're diving into the hidden architecture of databases, and we're going to look at them not just as a bunch of code, but as the master blueprint for all of our data.
Okay, so let's just start with a huge question, right? Think about the scale we're talking about. How in the world does a company like Amazon or Google manage billions of transactions or trillions of web pages without the whole thing just imploding into total chaos?
Well, the answer is, believe it or not, kind of elegant. You can't just dump all that information into a digital shoebox and, hope for the best. No way. It all starts with a plan, a really detailed, carefully thought out plan.
So that's going to be our starting point. We're diving into this plan, what we're calling the database blueprint, and we're going to see exactly how it brings order from all that potential chaos.
All right, so the official, kind of nerdy term for this plan is a data model. It's just a collection of ideas for describing your data, how it all connects, and the rules it has to follow. But honestly, let's just stick with our analogy. It's the master plan you draw up before you even think about pouring the foundation.
And just like building a house, any good plan really has two fundamental parts, doesn't it? You've got the design, and then you've got the real thing.
And this brings us to a really, really important idea. On one side, you've got the schema. That's our blueprint. It's the set of rules. It says, hey, every student record must have an ID, a name, and a major. It's the structure. Then on the other side, you have the instance. That's the actual house, the real data, right now. It's John Doe, student ID 101, majoring in computer science. See the difference? The blueprint, the schema, that's pretty stable. But the data inside, the instance, that's changing all the time. Okay, so we've got this master blueprint. But who actually gets to see it? And how much detail do they really need? This leads to a brilliant solution. The idea that there are 3 different levels of detail. 3 different ways to look at that one single plan.
Think about it, right? If you were building a house, you wouldn't hand the complete, super complex architectural, electrical, and plumbing plans to the person who's just buying it. Of course not. It'd be totally overwhelming. So what do? You create different, simpler views for different people and different jobs.
This whole concept is called the 3-schema architecture. It basically gives us 3 views. You've got the user view, which is the external schema. Then there's the big master plan, the conceptual schema. And finally, the super detailed foundation level, the internal schema. Let's break each of those down.
First up, the external schema. This is what you, the user, actually interact with. Think of it like a glossy real estate brochure. It shows you the pretty stuff, the living room, the kitchen, but it hides all the complex, messy details about the wiring and the plumbing. So, for example, a university registrar might see a student's grades, while the financial aid office sees their tuition status. It's the same underlying data, but they're looking at it through totally different, customized windows.
Okay, moving a level deeper, we have the conceptual schema. This is the architect's master plan. It describes everything, the whole logical structure of the database, all the entities, all the relationships. It is the one single source of truth. And this is key. This plan doesn't care how the data is stored. It doesn't care if the foundation is made of concrete or steel, It's all about the logical design, completely separate from the physical stuff.
And finally, we get down to the internal schema. Now we're in the nitty-gritty. This is the contractor's view, the actual wiring diagrams, the plumbing layouts. It describes exactly how the data is physically organized on the hard drives. We're talking files, indexes, storage structures, all the stuff that makes it run fast. And just like a house can only have one foundation, a database has only one internal schema.
All right, so we have this really elegant 3-layered blueprint. That's great, but how do we actually use it? How do we read the plans, build the house, and then, put furniture inside? Well, for that, you need a special set of languages.
Yeah, because you can't just talk to a database in plain English and expect it to understand you. To actually define that structure and then manage all the data inside, you need a special set of languages that are designed specifically for that job.
And here are the big ones. First, you've got DDL, the Data Definition Language. Think of this as the language you use to draw the blueprint, with commands like create. Then, to furnish the house, you use DML, the Data Manipulation Language, to insert new data or update old stuff. DCL, the Data Control Language, is like handing out the keys. You grant access to some, revoke it from others. And finally, TCL, or Transaction Control Language, is for managing those big renovations, making sure they either commit successfully or roll back if something goes wrong.
So you might be thinking, okay, why? Why go through all this hassle of separating everything into 3 different layers? What's the big payoff here? Well, it all comes down to one incredibly powerful idea: independence. Or, keeping with our analogy, let's call it the freedom to renovate.
Okay, so here's the book definition. Data independence is the ability to change the schema at one level without messing up the schema at the level above it. And let me tell you, this is basically the holy grail of good database design.
And it comes in 2 flavors. First, there's logical independence. This means you can change the master blueprint, let's say you add a new bathroom, without forcing the people living there to relearn how to use their front door. The old stuff still works. But then there's physical independence, which is maybe even more powerful. This means you can completely rewire the house, change the foundation, swap out the plumbing, and the architect's master plan doesn't have to change one bit. The applications on top have no idea anything changed underneath.
So what's the real point of all this? The payoff is huge. It means your apps don't break every single time the database gets an upgrade behind the scenes. Developers can completely optimize the backend, that deep internal level, without breaking every single app that talks to it. It's the magic trick that gives us both stability and flexibility.
And honestly, the difference is night and day. Before this idea, if you wanted to change how the data was stored, you had to rewrite the app. It was fragile, it was expensive, it was a nightmare. Now, with independence, you can totally renovate the foundation and the app just keeps on chugging along, happy as can be. It's a total game changer.
And that quote right there just sums it all up perfectly, doesn't it? This architecture, this whole blueprint idea, is precisely why your favorite app can get a massive update behind the scenes. And yet, for you, it still works exactly the same way. So let's leave it with this final thought. We're always talking about apps and code and algorithms. But without these fundamental blueprints for organizing data, could our digital world even exist? Could our social networks, our banking systems, the whole internet, could any of it have been built to the incredible scale we see today? It's something to think about.